In this video we're going to talk about how to find the area of a regular polygon. And this is just one example, but to start I want to talk first about what is a regular polygon. So a regular polygon is a polygon in which all the sides and the angles are congruent. So every single side has the same length as every other side, and every single angle has the same measure as every other angle. Now, one word that you hear mentioned a lot in these problems is this word here, apothem or apothem, different pronunciations you'll hear. And what that is just this dotted segment here in my picture, where it's a segment that goes from the center of the polygon, then down perpendicular to one side of the polygon, and that's an apothem or apothem. Alright, so we don't necessarily need those right now, so let's just move them off to the side. Now the easiest way for me to find the area of this polygon is to just divide it up into different triangles. So I can see that they've sort of already started that for me. We've got this one line drawn here, and then the apothem cuts it into another little triangle. So I'm going to go around and divide it into some triangles, sort of like that. I'm actually going to use triangles that are a little bit bigger. So I'm going to go from the center and then down here to each vertex, which, since there are 8 sides, we'll be creating 8 triangles. And since it's a regular polygon, all 8 triangles should be the same. And then I'm just going to find the area of each of those triangles. And so we remember that the area of a triangle, so let's maybe just a little bit. The area of a triangle, we should know that formula. A is equal to 1/2 base times height. Now each of my purple triangles over here, since they are all congruent, each purple triangle should have a base of 10, and then the apothem is actually going to be, and forgive my sort of crooked triangle there, the apothem is going to be the height. Unfortunately, in this problem, they didn't give me the apothem. So I need to figure out how I can possibly find the apothem here. So the way I'm going to do that is I'm going to look at some angles here. When I look at this picture, this octagon, I see that around the middle here, of course, we have 360 degrees all the way around. But then I cut that into 8 pieces, and then the height of each triangle actually cuts it into 16 pieces. So I'm just going to be looking for these little angles here created between one side of the triangle and the apothem. So to find that little angle, we're going to do 360 divided by 16. And again by 16 because we have 8 triangles, and then we're looking at the angle that's just formed by half of that triangle. If you do that division, you'll get 22.5. Now if you had a different type of polygon, say a hexagon or a pentagon, then you wouldn't divide by 16. You just look at the number of triangles you have and then divide your 360 by that. So that angle then is 22.5 degrees. And I need to use that angle to help me find the length of my apothem, or the height of each of these little triangles. And to do that, I'm going to use trigonometry. So I'm going to look just at sort of one of these half triangles here, where it's formed with the apothem there. Now, so I know the base of this little triangle is 5, and I know that this 22.5 degrees goes here, because it also went here, And remember that that came from here in the original picture. And again, what we're looking for is the height of this triangle, which is this little segment here that I'll call A, since it's the apothem. Now, if I know this angle at the top, I know this side at the bottom, and I'm looking for this side that's right next to it, that's the opposite leg and the adjacent leg. So I'm going to use tangent to find that. So tangent of 22.5 is equal to opposite, which is 5, over adjacent, which is A, the apothem. To solve this, I like to turn this into a fraction and then cross multiply. You don't have to do it this way. I think it sort of makes it always the same, so there's a little bit less guesswork there if you have trouble remembering, do I divide, do I multiply, what do I do? I turn this into a fraction so then I can just cross multiply. So I get A times the tangent of 22.5 equals 5 times 1, which is just 5. I like to put my tangent of 22.5 in parentheses like that, just so I remember that the tangent of 22.5 is one thing together. It's not the tangent and then the 22.5 separately. It's one whole thing. Now I want A by itself, so since it's A multiplied by a tangent of 22.5, I need to divide by my tangent of 22.5. So that will cancel out. And then, of course, whatever I do on the left, I must do on the right. And so then I just need to ask my calculator, what is 5 divided by the tangent of 22.5? And you should get approximately 12.071 inches. I like 3 decimal places, so that's what I always use. And that's the height, A, of my triangle, which is, we called it A because it's the apothem in the figure. So now to find the area of the triangle, we're going to say that area A is equal to 1/2 times the base, which for this whole triangle here is 10, times the height, which we just found was 12.071. Multiply that all out, and you'll get approximately 60.355 inches squared. And that's for the area of the triangle. But each of these purple triangles, each one of these purple triangles that we just found the area of, represents just part of the octagon. And since there are 1, 2, 3, 4, 5, 6, 7, 8 of those triangles for the whole thing, then my total area, or the area of the octagon, is going to equal that area of the triangle times 8. 8 times 60.355 inches squared gets me 482.355 inches. Oops, I'm sorry. I was looking at the wrong. That wouldn't make sense. 482.843 inches squared. And that's the area of the octagon. Now in some problems they're going to switch things around on you. Here they gave us this side length and we had to use some trigonometry to find the length of the apothem so that we could do this. Other times they'll switch it and they'll give you the apothem and you have to find the side length. You do the same basic thing. It's a little bit different, but it's basically the same thing. Here we knew the side length, had to work to find the apothem using trigonometry. Other times they'll they'll give you the apothem. You have to work to find the base using trigonometry. It's basically the same thing. Now there is a shortcut for doing this, and it's a formula that they give in some books, that the area of a regular polygon, A is equal to 1/2 big P, which stands for the perimeter of the polygon, times A, which is the apothem. And I'll leave you to figure that out, why that's really the exact same thing as what we did here. It really is exactly the same as what we did here. I like to do it this way just because it's one less formula to remember when I'm thinking about all my area stuff. As long as I know how to find the area of a triangle, I can find the area of a regular polygon. Okay, so that's how you would find the area of a regular polygon. Enjoy.